Cosmic secrets revealed. Beyond time, beyond space, beyond imagination.
Have you ever looked up at the night sky and wondered where it all came from? And where it's all going? From the first fiery instant after the Big Bang to the distant cold future where even the last stars fade away, the universe has a story. It's an epic timeline, 13.8 billion years long, and it's still unfolding. It's a story of creation, destruction, and incredible transformation. And today, we're going on a journey through it all. We'll travel from the very beginning, through the birth of stars and galaxies, witness the dawn of our own planet, and then venture far into the speculative future, to the very end of time itself. So buckle up, because we're about to explore the entire history and future of everything. This is the timeline of the universe. Let's rewind the clock all the way back, 13.8 billion years ago. Before stars, before galaxies, before space itself as we know it. Imagine everything, all the matter, all the energy, even time and space, compressed into a single, infinitesimally small, incredibly hot and dense point. Then, in an event we call the Big Bang, it all erupted. This wasn't an explosion in space. It was the explosion of space. In a fraction of a second, a period known as cosmic inflation, the universe expanded faster than the speed of light, stretching from the size of an atom to the size of a grapefruit and beyond. In this primordial soup of pure energy, the fundamental forces of nature split apart, and the very first particles, quarks and electrons, materialized. These were the fundamental building blocks of everything we see around us today, forged in the first, most violent moments of existence. The universe was born, and its incredible journey had just begun. For the next 380,000 years, the universe was a hot, dense fog of charged particles and light. Light couldn't travel far without bouncing off an electron, so the cosmos was completely opaque. But as the universe continued to expand, it cooled. Eventually, it cooled enough for electrons to be captured by atomic nuclei, forming the first stable atoms, mostly hydrogen and helium. This event, called recombination, was a game changer. Suddenly, light was free to travel unimpeded across the cosmos for the first time. This first light is something we can still detect today. It's called the cosmic microwave background radiation, a faint afterglow of the Big Bang that fills the entire sky. The dark ages of the universe began, a period of quiet before the first stars lit up the darkness. But within this darkness, gravity was silently at work, pulling the newly formed atoms into massive clouds, setting the stage for the next brilliant chapter. Around 200 to 400 million years after the Big Bang, those vast clouds of hydrogen and helium, under the relentless pull of gravity, began to collapse in on themselves. At their cores, temperatures and pressures soared until nuclear fusion ignited. The first stars were born. These weren't like our sun. They were giants, hundreds of times more massive, burning incredibly hot and bright, bathing the young universe in brilliant blue light. They lived fast and died young, exploding in spectacular supernova after only a few million years. These explosions were crucial. They forged heavier elements like carbon, oxygen, and iron inside their stellar furnaces and then scattered them across the cosmos. These new elements seeded the next generation of stars and provided the raw materials for planets. Meanwhile, these stars and the dark matter that surrounded them began to cluster together, forming the first infant galaxies and laying the foundation for the grand web-like structure of the universe we see today. Fast forward several billion years. The universe is now a bustling place filled with countless galaxies, each swirling with billions of stars. In a quiet, suburban corner of one of these galaxies, the Milky Way, another giant cloud of gas and dust began to collapse. About 4.6 billion years ago, at the center of this swirling nebula, a new star ignited, our sun. The remaining material didn't go to waste. it flattened into a spinning disk around the young star, a protoplanetary disk. Within this disk, tiny grains of dust and rock began to stick together. Through a process called accretion, these clumps grew larger and larger, from pebbles to boulders to planetesimals, and finally, into the planets we know today. In the hotter, inner part of the solar system, rocky worlds like Mercury, Venus, and Mars formed. And in a perfect Goldilocks zone, not too hot, not too cold, a small blue planet took shape. This would become our home, Earth. For the first few 100 million years, Earth was a hostile world, a molten ball of rock, bombarded by asteroids and comets left over from the solar system's formation. But these very impacts delivered a crucial ingredient: water. As the planet cooled, this water condensed, forming vast global oceans. And somewhere in these primordial waters, a remarkable chemical reaction occurred. Simple organic molecules assembled into complex structures that could replicate themselves. Life had begun. At first, it was just simple, single-celled organisms. But over billions of years, through the engine of evolution, life diversified into a breathtaking array of forms. It survived ice ages, mass extinctions, and planetary upheaval. It filled the oceans, crawled onto land, and took to the sky. And eventually, on one small branch of this tree of life, a species emerged with the capacity for consciousness, language, and technology. A species that could look up at the stars and not just wonder, but understand. We became the universe's way of knowing itself. Our story, and Earth's story, is just a fleeting moment in the cosmic timeline. The universe will continue its journey long after we're gone. What does the future hold? Well, in about 5 billion years, our sun will run out of hydrogen fuel. It will swell into a red giant, likely engulfing Mercury, Venus, and possibly even Earth, boiling our oceans and sterilizing our world. After that, it will shed its outer layers, leaving behind a small, dense stellar corpse, a white dwarf, that will slowly cool over trillions of years. This will be the fate of most stars in the universe. More massive stars will end their lives in brilliant supernova explosions, creating black holes or neutron stars. Across the cosmos, galaxies will continue to drift apart, pulled by the accelerating expansion of the universe. Eventually, the night sky, as seen from any remaining worlds, will grow dark, with neighboring galaxies having receded beyond the visible horizon. As we journey into the truly deep future, the universe becomes an almost unrecognizable place. Trillions of years from now, star formation will have ceased entirely. The only light will come from the dim glow of dying white dwarfs and neutron stars. The dominant objects in the cosmos will be black holes. These gravitational behemoths will continue to swallow any matter that drifts too close, growing ever larger. But even they are not eternal. According to Stephen Hawking's theories, black holes slowly evaporate over incomprehensibly long timescales through a process called Hawking radiation. A stellar mass black hole might take 10 to the power of 67 years to disappear. The supermassive black holes at the centers of galaxies could take 10 to the power of 100 years. It's a timescale so vast it's almost meaningless to the human mind. The universe will become a cold, empty void, populated only by stray photons and elementary particles. What happens after the last black hole has evaporated? This is the era of heat death. The universe will be a vast, dark, and unimaginably cold place, approaching a state of maximum entropy, where all energy is evenly distributed and no work can be done. It will be a near-perfect vacuum, silent and still. All the brilliant structures, the stars, the galaxies, the planets, the very memory of life, will be gone, dissolved into a uniform, low-energy soup. Time itself may lose its meaning, but even in this final quiet state, the story of the universe remains. It's written in the fundamental laws of physics and in the faint residual radiation that will persist for eternity. We are a part of that grand cosmic story, a brief but extraordinary flash of awareness in the vastness of time. Our existence, however fleeting, has added a chapter of wonder and discovery to the timeline of everything. Thank you for joining us on this incredible journey through space and time. It's a humbling and awe-inspiring story to consider. If you enjoyed this cosmic exploration, please give this video a thumbs up and subscribe to the channel for more adventures into the mysteries of our universe. And don't forget to hit that notification bell so you won't miss our next video. We'll see you then.